So we've been talking about quadratics for a while now. Let me do some quick review of sort of the basics we have to understand before we move forward. If you have equations, and equations mean you have an equal sign somewhere, so if you have an equal signed expression somewhere with only one variable, then solving that equation is quite simple. You just get the variable by itself. We usually follow SADMEP when we're solving, which is the order of operations backwards. So add 8 to both sides in this case, divide both sides by 6, and you get that x equals 3. And even with a square, this one's a quadratic, the steps don't really change. Add 5 to both sides, divide both sides by 2, and square root both sides. And remember, when you square root, you're going to get a plus or a minus. The solutions here are plus or minus 3. If there's only one x, only one variable, solving is very simple. If there's two variables, we have to get tricky. Maybe the equation is factorable. Some expressions can be factored. If they can be factored, they can solve pretty easy. This one factors into 2x squared plus 2x plus 9x plus 9. Cut it in half and pull a 2x out of here, and pull a 9 out of the other side. So this becomes 2x plus 9 times x plus 1, which means that my solutions are going to be x equals -1 or x equals -9 over 2. You just take your two bubbles and set them equal to 0 and solve. So if the equation can be factored, solving is pretty straightforward. And remember, in general, when we're solving, we're finding roots, okay? So like, if we were to look at this equation right here, if I were to sketch a really quick graph of this, it has a y-intercept at 9. It has an AOS at -5.5. So right here. But it has roots at -1. Oh yeah, sorry, this is the wrong AOS. This is incorrect. Roots at -1 and -4.5. So the AOS is actually going to be right about here. When you're solving, you're finding roots. The roots are -1 and -4.5. So we can find roots by solving these quadratic graphs. Okay, but if something can't factor, right, this could factor, but say we get something that can't factor like this. If I multiply a times c, I get -20. There aren't two things that multiply to -20 and add to +5. This can't factor, but it can be solved. I know it can be solved because the y-intercept is negative. It's way down here, but the graph is pointing upwards because the a value is positive. So something like this is happening, which means there are roots somewhere. And since there are roots somewhere, this equation can be solved. If you have an equation that can be solved but cannot be factored, we're going to use the quadratic formula. Okay, the quadratic formula is this big old concoction of letters and numbers over here on the side that looks like a real mess, but it's actually pretty straightforward to calculate. Okay, so the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. So we're finding an x value, that's why it's x equals. We're solving for x, but it involves the a, b's, and c's from here. So let's solve this one. A is 2, b is 5, c is -10. When you are doing the quadratic formula, the first thing you want to calculate is the b squared minus 4ac. So I'm just going to first calculate b squared minus 4ac. Well, the b value is 5, the a value is 2, the c value is -10. When you're calculating b squared minus 4ac, do this as one piece and do all of this. I'm going to change colors here. Do all of this as another piece. So I'm going to make this positive 25, and then -4 times 2 times -10. -4 times 2 times -10 is going to be positive 80. So I get positive 105. So the b squared minus 4ac, this came out to 105. So when I'm doing the quadratic formula, I can now type or write x equals -b, which is -5, because b is 5, plus or minus the square root of, but I've already calculated b squared minus 4ac, it's 105, all divided by 2 times a, and a is 2. So it's x equals negative 5 plus or minus the square root of 105 over 4. Okay, and let's just leave this like this for now. I think in our next lesson we'll talk about how to calculate this in your calculator. But for now, let's just leave it like this. If 105 could break down, I would break it down. But it can't. 105 is 3, 7, and 5. So this is just going to be how I'm going to leave the solution for now. And I get this doesn't look like much of a solution, like what does that really mean? But it is. That's our solution. Like I said, eventually we'll calculate this and find the decimal. But for now, we'll stay here. So let's just do the quadratic formula 3 more times for practice. Identify A, B, and C in all 3 of these problems, please. Take a second, identify A, B, and C. Oh, and these should all be equal to 0. The quadratic formula only works if it's equal to 0. So let's do this. I'm going to change one of these real quick. Let's make this one equal to 3. The quadratic formula only works if you're equal to 0. So if you aren't equal to 0, make yourself equal to 0. Like on this problem here, which I made equal to 3, we would start by subtracting a 3 from both sides and get 2x squared minus x minus 3 equals 0. So if you get an equation not equal to 0, make it equal 0 and then solve. Well, for number 1, our a value is negative 4, our b value is negative 6, and our c value is 2. I'm first going to calculate the b squared minus 4ac. b squared minus 4ac becomes negative 4 squared minus 4, negative 6 squared, because b value is negative 6. Negative 6 squared minus 4 times negative 4 times 2. Well, negative 6 squared is positive 36. If you're ever doing this in your calculator, you have to be very careful that your squaring comes out positive. Negative 6 squared is positive 36. I'm doing 4 times 4 times 2. Negative 4 times negative 4 times 2. Well, negative 4 times negative 4 is 16. 16 times 2 is 32. This is plus 32. See, since this all came out positive, I put a plus here. So one thing that can be worth doing is to start by just looking at this and thinking, is this going to come out positive or negative? It's a negative times a positive, so it's going to come out positive. 36 plus 32 is 68. Well, now I can do the quadratic formula pretty quickly. X equals negative b. Well, negative b is negative 6. So negative b is actually going to be a positive 6 plus or minus the square root of 68 all divided by 2 times a. All divided by 2 times negative 4, because the a value is negative 4. So this becomes 6 plus or minus the square root of 68 over negative 8. Now I want to see if that root 68 can break down, if it can be simplified. So 68 is 2 times 34. 34 is 2 times 17. 17 is prime, but here's a pair of 2's. So the pair of 2's means this can simplify. This means that root 68 is really the same as the square root of 4 times 17. And I can square root the 4 to make this 2 root 17. This will become 6 plus or minus 2 root 17 over negative 8. Now, I have to check all these coefficients. So I don't check the number inside the square root, ever. Like, for example, this 68 and this 8, I don't try to simplify or reduce, because one's inside a square root, one's inside a radical, and one isn't. But I check the numbers that are outside the radicals. Since all of these can divide by 2, I'm going to cut every number in half and have this. I just reduced the fraction, divided everything by 2. And just so you know, most of the time you'd see it written like this. We would take the negative and move it to the top. I don't need you to do that right now, but if you wanted to get in that habit, that might be a good idea. Okay, let's do the next one. Next one, the a value is 2, the b value is negative 1, the c value is negative 3. So I set up the b squared minus 4ac. This is called the discriminant, for the record. The actual b squared minus 4ac is called the discriminant. When I calculate b squared minus 4ac, it's going to become negative 1 squared minus 4 times 2 times negative 3. Negative 1 squared is positive 1. This is going to become positive 24. and 1 plus 24 is 25. Well, this is going to be really nice because 25 is a perfect square. So when I do the square rooting, it's really clean. So I have x equals negative b, and negative b is positive 1, plus or minus the square root of 25 all over 2 times a, and a is 2. But root 25 I can calculate. This is 1 plus or minus 5 over 4. When you can get a nice, clean, perfect square out of this, you just keep going and do all the solving. So I'm going to step down here and make two equations now. I have 1 plus 5 over 4 and 1 minus 5 over 4. Well, 1 plus 5 over 4 is 6, and 6 over 4 is 3 over 2. 1 minus 5 is negative 4, and negative 4 over 4 is negative 1. So my solutions are actually really clean here. X is going to be in the set negative 1 and 3 over 2. Okay, last one. Now for the record, this can actually factor, right? We can factor this into x times x minus 5, and it can solve very easily. X equals 0 and x equals 5. So if you can factor, you should factor. This one also could have factored, actually. But we're going to keep practicing the quadratic formula for now, because that's the goal of this lesson. So my a value is 1, my b value is negative 5, my c value is 0. And that's okay to have a c value or a b value of 0. So I'm going to do the discriminant b squared minus 4ac, which is 25 minus 4 times 1 times 0, which is actually just 25 because all of this is 0. 4 times 1 times 0 is 0, so this just becomes 25 again. It's going to be really similar to our last problem, actually. So now we're going to have negative b. I'm doing the quadratic formula here, right? So negative b is positive 5 plus or minus the square root of 25 all over 2. Well, this is 5 plus or minus 5 over 2, which is going to be either 5 plus 5 over 2 or 5 minus 5 over 2. So it's 10 over 2, which is 5, or it's 0 over 2, which is 0. So this is my solution set, just like I got when I factored it. Okay, that's a lot of practice of the quadratic formula. We'll do it more, and we'll also do it again in our next lesson. So it's a great way to be able to solve any type of quadratic. The main thing to be aware of is when you have the negative b, if your b value was already negative, you have to make it positive. It's a tricky thing to be aware of. B squared will always come out positive, so that's nice. You don't have to worry about positive or negative with b squared. But with this negative b term right here, if your b value starts negative, it becomes positive. If it started positive, it becomes negative. Other than that, start by calculating the b squared minus 4ac, which is called the discriminant, and we'll be good to go.